webinar. We'll wait 5 minutes for guests to sign on before we begin. Thank you for joining the webinar. We will wait 5 minutes for guests to sign on before we begin.
Welcome to
Thank you for joining the webinar. We will wait 5 minutes for guests to sign on before we begin. Thank you for joining the webinar. We will present our presentation shortly. Thank you for joining the webinar. All attendees have been placed on mute. This webinar will be recorded. If you do have a question you would like to ask, please type it in the chat box and we'll answer your questions during the presentation. If you're having trouble seeing or hearing the webinar, please let us know. If you're experiencing an echo and are using audio through your computer, you may want to try calling in using a landline telephone. This webinar is brought to you by Build It Green. Build It Green is a member-supported nonprofit organization working to expand the market for green homes in California. Our webinar presentation today will outline how to stay up to date with plant and systems modeling, as well as current design strategies for multifamily buildings. This webinar will provide raters and energy consultants with knowledge on the basics of multifamily residential building modeling using Energy Pro 5. We will also discuss identifying modeling best practices as it relates to new and existing multifamily homes and illustrate how to troubleshoot Energy Pro calculations. Our speaker today is Sean Furtado. Sean has been an AutoCAD designer for commercial engineers, architects, and design-build construction companies in California. With experience in energy modeling and energy compliance, he has been involved in helping make homes more energy efficient. Recently, he has joined the Build It Green Quality Assurance team to assure that models are coherent and reflect correct savings. Sean, the floor is yours.
Hi, just before I get started, I want to make sure the chat box is working. So if you folks could just let me know what kind of professional you are in the industry. Are you an architect, an engineer, a rater? Just go ahead and put that in the chat box, and I'll give you guys a minute. Okay, good. Looks like we have some inputs. We have some raters, some consultants, some energy analysts, as well as some engineers, and some HERS raters. We also have some Title 24 consultants as well. So great. So as Diana already explained, I'm a certified energy plan examiner. My lineage and my background is really drafting and communicating plans and construction implementation. So this webinar will specifically be talking about plants and HVAC systems. So that's we're going to be doing greenhouses today. No, it's a joke. So we're actually doing plants as far as water heating systems and HVAC systems for both low-rise and high-rise residential buildings. Okay, so first slide. Plants and HVAC systems. So these systems have the biggest opportunities for energy savings. Given the scale of their usage, we're going to be specifically looking at these components in the energy modeling, as they have the biggest potential for showing you savings. We won't be discussing low-hanging fruit items like low GPM flow rates or air sealing strategies or anything of that type. Also, you maybe would want to, before you get started in any of your energy modelings, find out whether or not the HVAC system or the water heating system does have issues. You might want to find out if the tenants are complaining about it, about the space conditioning or hot water usage, and that may help you give you some design recommendations before modeling. So some other things to be advised of are
Welcome to GoToWebinar, Web Events Made Easy.
non-residential ACM manuals. And I've listed the links in both these bullet points, and the slides will be available later, so you can click on the links and go to the actual manuals. But all energy modeling software has to follow the 2008 ACM manual. Okay, just be advised of those things. You also, for best practice advice for modeling, you might want to sit down and familiarize yourself with the California Title 24, Part 6. It's also a good idea you familiarize yourself with plumbing and mechanical codes. If that's not feasible, having some knowledgeable staff person or consultant who knows HVAC systems or plumbing systems, who can help you troubleshoot design specifics or code issues or even controls that someone who does the energy modeling might not know is very key. Also, in your Energy Pro documents, there is a list of start files, if you would call it, or templates. I don't really want to call them templates. They're just kind of something you can look at just to give you an example of how to build systems out. So if you open up your Energy Pro 5 folder in your My Documents, there should be a library with an assorted style, a bunch of different models with different applications, whether it be high-rise, low-rise, single-family, commercial buildings. But each of these examples do have do show great breakouts of how to design some of these plants and HVAC systems. So that's always a good idea if you don't have someone you can call and figure out how to model a certain system. Another good best practice is to not duplicate or reuse your old files. The file duplication process I've found has caused some file corruptions, and calculations will just come out a little wacky. And also past information that you might have used for a prior model might be overlooked and may cause a building to not comply or not meet savings. So my best practice is always start fresh and give yourself time to do a full Energy Pro BLD tree, or give yourself time to be able to check an existing file to make sure there aren't any corruption issues. Okay, so let's jump right in. So first, we're going to jump into the plants, and found this awesome looking picture of this guy from I think the 40s, I want to say, or the 30s, with these old Scotch Marie steam boilers, and I thought that was interesting, so threw that in there. Pretty much boiler rooms back in the day. So the common types of domestic hot water systems or plant systems are steam boilers, hot water boilers, as you all know, are typical in a lot of multifamily systems. You do see central standalone storage tanks and individual standalone storage tanks in each dwelling unit. These both can be small storage, 50-gallon and lower, or large storage, or 50-gallon and higher. And you can also, you might or may not find tankless water heaters. I know in different countries this is typical for domestic hot water systems, that you have a tankless system. And you might also see in some newer, or maybe even some older multifamily buildings, solar thermal systems or PV systems that power that complement hot water generation. And also in new emerging technology are heat pump water heaters, which we'll go into in a little bit later in the alternatives section. So those are the typical, or the most common types of plant domestic hot water systems you'll run into for multifamily systems. Fuel types for these systems: natural gas, of course, electricity being the two primary fuel types in California. Solar is always great. Things we won't see in California: liquid petroleum, gas, solid fuels like wood and coal, and fuel oil. We'll see that mostly on the East Coast. But there may be some instances where you'll see some of these other fuels used, but it's probably really, really rare, and especially in a multifamily setting, given that these fuel sources are more for like people off of a grid. So some areas of consideration when you're looking at these domestic hot water systems or plants are the distribution system controls, so the temperature controls, the modulated temperature controls, and also just checking. You also want to see if you can reduce supply demand. The distribution system design, you want to always pipe or do a map of the pipes for in the boiler room. See if there's a recirculation flow control or any type of flow control. Look for timers, return temperature controls, any kind of on-demand control. And also a good idea is to see if they have a system in place for pipe cool down. And you also want to look at the water heater equipment, which we already went into as the different types up here. So when you're diagnosing domestic hot water systems or plants, for multifamilies, you should always find out how many people stay in each apartment. You want to find out how many bathrooms each apartments have, how many appliances, such as washing machines, dishwashers, anything that requires a hot water demand, and find out if the dishwasher has its own hot water heating arrangement. It's very rare and unlikely if the apartment may have a pool or a spa. This may be in a really high-income condo setting or something. And does the dwelling unit contain garden tubs or whirlpool baths? I think that's a little more typical. So you all should be familiar with what Energy Pro looks like. So this is pretty much the front page. So I'm not going to be opening up Energy Pro, and I will not be going into details on how to build out each component in the tree. So this webinar is specifically looking at the domestic hot water section and the HVAC section. So you should already know how to get to that component of the model. Okay. So I'm going to stop real fast to see if anyone has any questions. Go ahead and type it in. I'm going to give you guys a second. Okay, I don't see too many questions, but the question on the standby loss, I will get to that later. So hold tight. And you can always feel free to type in a question anytime you feel like you need something clarified, or if I didn't make anything clear. Just go ahead and type it in. And I'm going to be periodically checking the chat box to see your questions, and I'll make pauses throughout the webinar to answer these questions, so that way I can get to them while they're hot. Okay, so you all know the domestic hot water or the plant icon here in Energy Pro. Kind of put a little icon just to symbolize it up in the top right-hand corner. So if you're not familiar with Energy Pro, this is the section we'll be working in. So plant water heating systems. So you want to model the building's water heating systems, and you want them to be attributed to whatever zone or HVAC systems they're serving. I'll go into that a little bit later, but just to get the gist of it, you want your domestic hot water system serving the correct areas. You don't want to have one domestic hot water system accounting for the whole building when there are really a few different types, maybe one for a common area space, or one for the actual dwellings. So you don't want to include your commercial and your actual dwelling unit space water heating all in one system. You want to separate them out. And this tab here basically shows that, but we'll get into that later. So the tabs in the domestic hot water section that we're going to be looking at are the hot water tab and the domestic hot water tab. You want to make to distinguish the difference between the two. The heating hot water tab is basically for your your hydronic systems for your radiators or your any type of space heating. And so that's if you have a boiler that's doing hydronic heating, like for the radiators, you want to include your information on the system in this tab. And also to include on that tab, you want to include any pump information, any of the flow controls, and any of the type of recirculation systems. And I've pictured that on the right-hand side of this slide. And similar with the domestic hot water tab, you want to get the same information, but the difference with these two tabs, the domestic hot water will account for any domestic hot water usage. So when you're doing your calculations at the end, everything you modeled in this tab will show up in the domestic hot water tab. Anything you model in the heating hot water tab will show up in the heating loads. So just to differentiate the two usage here. So again, when you're modeling your plant systems, make sure you have the correct systems associated with that. So in this example here, I have a high-rise that had an actual commercial space with 2 HVAC systems and the actual residential space, hot water system, and the systems serving under that water heating system. So the first floor basically had one system, and the second through the 12th floors had a central system. And so both boiler and domestic hot water tab, the information will be very similar. You want to get the correct type, include the system name. If you can always get the nameplate name here. So like that's the model number and the manufacturer. So let's say Raypack A55C, something like of the sort. You always want to put in the fuel type, the volume. Most boilers will have pretty much no volume, but they're pretty much similar to tankless systems. The correct input and the recovery efficiency and the standby loss. The standby loss is calculated by using the 2008 Residential Compliance Manual. There's a section called the Appendix B-7B, Appliance Efficiency Standards, and this slide here goes into that table. So you'll just have to reference this table given the type of system you're going to be installing or the type of system you run into. So you're going to need to know the capacity of the system as well as the volume. And I've also included the link to this, to the actual reference. And like I said, the table can be found here at the Appendix B7. So we'll give you that. We'll give you the slides, and you can find the link and figure out how to do the standby loss. Okay. So I'm going to check the questions here. Okay, nothing related to the slides. Okay, so what does EnergyPro use for calculating the loads? So the EnergyPro is using the 2008 for low-rise 2008 residential ACM manual. In this the ACM manual, there's an Appendix E, section E6. It gives you detailed calculations for all the modeled loads, and that's for low-rise. For high-rise, EnergyPro uses the 2008 non-residential, that's a typo, excuse me, non-residential ACM manual, and this is section 2.6, and it also shows detailed calculations for modeling loads. So other relevant information that's in the plant tab, the plant icon. So let me go back here. So these tabs here that you want to include. So if you have a chiller system, that would go into the chilled water. And you want to find out what kind of chiller, I don't have a slide for that, but you want to find out what kind of chiller it's there. And you also want to get information on the cooling tower pumps and the cooling tower. And also if there's an energy management system for this cooling tower. Another relevant tab is the hydronic tab. So you typically use this for ground source heat pumps or even with your combined hydronic systems. The other tab is the renewables tab. And in this renewables tab, you're going to be modeling your solar thermal. And for your solar thermal, you need to do a CEC solar hot water calculator, and that basically gives you a solar fraction, which you're going to be putting into the EnergyPro percentage of how much hot water or fuel it's going to be supplying the system. And so when you're doing your, when you're looking at your loads, solar hot water will go into your domestic hot water loads. It'll just basically give you a reduction. And if you're doing Title 24 compliance, you won't see credits for any of these renewables. And if you're doing Greenpoint rated or using the res or non-res performance modules to get credits, these will show up. Okay, great. So the hot water pumps are included into when you're into these tabs here. This is basically what you'll see in the this tab. You'll see information for the pumps and the hot water pumps, and they're very similar between the hot water tab and the domestic hot water tab, if that's clear. Okay, so as far as domestic hot water or plant alternatives and design strategies, so you always want to look at what's there existing and what's feasible for replacement before actually specifying it in a scope of work that gets sent to the energy modeler after everything's been signed and things get changed and you find that you can't install a system and the model's already been submitted. So you want to be able to find out if a system is feasible before it's best practice before you can get to the energy modeler, so that way things don't get rejected or kicked back. Solar hot water systems have a very huge savings potential. It's a very, very good option in many cases given the scale of domestic hot water usage for multifamily buildings. Swapping out fuel types can give you some savings, and it may give you reductions in certain cases. So depending on the type of system, the fuel type you're swapping out, there may or may not be savings. So you may want to give yourself time just to consider that in the design phase. Standby loss for large storage water heaters. I gave you guys the list, but typically you want it when you find the test in there around 3%, and you want to test out at somewhere less than 0.5%. Domestic hot water distribution recirculation systems. So the only credit you can only really get with Energy Pro and multifamily systems is the point of use, because Energy Pro is already taking your baseline, is already having a recirculation system. So the only way to get credit for a recirculation system, which I showed back here, is really if you go from recirc to a point of use, which is really hard in a lot of application because this means that you're having the water heating system located within 8 feet of each fixture. It may or may not be possible given if the situation calls out that the actual building is gutted and you can actually get to the pipes. But in most rehab situations, this is not applicable. But in some new construction applications, point of use is a really good option. Boiler and DHW tune-ups are always a good low-cost option to improve system efficiencies, but Energy Pro won't give you any credits because there isn't a tab or any actual drop or a calculation that's been developed by the Commission that's approved, that shows an approved metric for tune-ups. And also another good design strategy for boiler rooms is this system called the AirTap A7. It's a heat pump retrofit onto an existing tank, and it's an air-to-water heat exchanger. I didn't put in a picture of it, but it basically takes any kind of hot air, which can be exhausting from the boiler room, and transfers that into the hot water. So I think that's a really good, excellent solution. And they have a 2.2 energy factor, so that's really can show some really high savings. And it's just a retrofit kit for around $1,000. And also, I didn't include a bullet point. You also want to make sure cost, that systems aren't going to cost the building owner a whole lot of money to install. So you want to get a system that's cost effective but yet has high savings potential, like this AirTap A7, which is only like $1,000 and has huge saving potentials. Okay, so let's jump into HVAC systems. So before I actually jump into that, I don't see any questions here in the chat box, so I'm going to assume that everybody's okay on the plant section. But if not, go ahead and type them in, and we can get to that later. So you would model the air tap as an air source heat pump. So I don't have the energy profile on this laptop, or the software on this laptop, but you would call it out as a heat pump and then put in the energy factor as 2.2. That makes sense, because it's a retrofit kit. So any more questions? Nope. Okay. So HVAC systems. So typically with HVAC systems, you'll see in multifamily buildings, you won't see a whole lot of rooftop package units. Maybe for a large-scale high-rise residential, you'll see fan coils. You definitely will see gas wall heaters of some type, and electric baseboard radiators. Those are the typical types that I run into when I'm looking at applications. And again, fuel types, very similar to domestic hot water, plant systems, natural gas, electricity. Very rarely will we see liquid petroleum gas or any kind of solid wood or fuel oil. Okay, so typical multifamily systems. So we have two types really, centralized and decentralized systems. Centralized systems can include a hydronic system. So going back to our hot water tab here that we talked about here. So this is the system that runs off this hot water from the boilers. So they can be either 4-pipe or 2-pipe. The difference between a 4-pipe and a 2-pipe is 4-pipe will do cooling and 2-pipe is just heating only. Many of you should already be familiar with steam systems, 1-pipe and 2-pipe systems. Central systems, this is new, the multi-zone mini-split systems. And built-up VAV, I've seen it maybe once. And chillers, of course, with water towers. Decentralized systems, you'll see fan coils. They have an integrated heat pump somewhere on the roof. You'll see electric baseboard radiators, gas-fired wall heaters, and self-contained package terminal air conditioner units or heat pumps, or ACs that go through the walls. Those are most typical types of systems you'll see in multifamily. Okay. So areas of consideration, of course, the distribution, the radiator controls, thermostat type. You also want to look at the distribution design, whether it's ducted or non-ducted, or if it's a fan or non-fan. So it's basically our radiator versus our PTAC or our wall unit. And of course, we're going to be looking at the HVAC systems and basically these types of systems. So also you want to do a dwelling unit summary, find out what the tenants are complaining about, if the units are getting too hot or too cold, and are there any combustion safety related issues. And you want to find out how many people stay in the apartment for ventilation reasons. You want to find out how many bathrooms the apartment has, also for ventilation reasons. Are the exhaust fans operable? Are the ducts connected? You want to look at these things. Is there enough CFM going through exhaust for in the kitchen, the exhaust fans? And of course, combustion safety related issues. I said that twice, but it's always important given that these buildings are most typically tight, and if there's any combustion safety related issues, they can potentially be problems for the occupants. So jumping into the HVAC section, our icon. So this is the section we're working in Energy Pro. So we're going to be looking at most of the tabs in Energy Pro. I wasn't able to get it onto this PowerPoint slide because it's just too small and blurry. But if you open up Energy Pro and you click on this space heating or your HVAC system, you'll see a variety of tabs. So most of them you're going to be looking into except for the MEC 2. And I think that's used in most commercial applications. I haven't really seen it used in residential applications. So there's the heating and cooling tabs. So the heating and cooling system should be documented when you actually did the assessment. You want to make sure you have the correct nameplate information. You want to make sure the correct systems are related to the correct buildings, and you definitely want to make sure you get all the systems that are involved in this building. You don't want to leave out components that that can be related to savings. So the heating and cooling tabs, you want to include the system type, basically whether it's a central system, or I'm sorry, a split system, a package system, or a 4-pipe or 2-pipe. Energy Pro has a drop-down. You should be familiar with this section, so you should know that the heating system type has a bunch of different configurations. You definitely want to know the fuel type. And also there's a fan tab when you're looking at the system details, and this is used to enter in any air handler or blower information. So if the system has a fan, you want to put that information here. If you have a baseboard radiator system, make sure that there's nothing in this tab. So I found a lot of times there's fan loads in baseboard radiators, so you want to make sure that's zeroed out or deleted. Most typically because they're used it got carried over from an existing file, so that's just a spot check for your load calculation. Another tab of importance for central systems, or if a system's on a fan coil that's ducted, is the duct distribution tab. So this is basically looking at what type of ducting system for heating and cooling, whether it's ducted or not, and the duct R value. And there's also a radio or a click button for duct leakage percentage. So if you're going to do a duct test, this is where you would put the duct leakage percentage that you found. And best practices duct leakage should be done by using duct leakage to outside, but you should consult the Hearst Technical Manual on all duct testing procedures, so that way you can get your numbers as accurate as possible for the model. The residential tab, so this tab is where you will set up your thermostat configuration, or the temperature controls, so to speak. So there's two drop-downs which I'm really going to be specifically talking about, and it's the thermostat setback or no setback. So this is whether or not you have a programmable thermostat or just a standalone solenoid thermostat where it's just on a little radio clicker, and you specify that based on what you find in the unit. So if you have hydronic space heating, like with the broiler or with the domestic hot water tank, there is a drop down in this section, the residential tab, for hydronic space heating for the boiler and the DHW tank. So going back to our prior tab, our hot water or plant system tab, if we're using hot water for our space heating, we're going to tell the thermostat that the heating hot water or broiler is providing space heating, and if the actual domestic hot water tank is providing the hot water for the radiators, or it's most likely not going to be a steam boiler doing domestic hot water. And well, it could be, but basically the gist of it is if this domestic hot water is providing the hot water, you will tell the thermostat that domestic hot water is providing, or if it's the heating hot water boiler that's providing it. So given the configuration, you would set up whether it's a domestic hot water or a boiler controls. Let's see, this section the residential section, you can also include any supply and exhaust ventilation. It'll ask you for a CFM and I believe a horsepower. I didn't include the slide, so I apologize. But the information on any kind of exhaust fans you should definitely document and include in this section of the Energy Pro model. Okay. Okay, so I'm going to go ahead and look at the questions real fast. Give me a second to read over them. So I'm a little confused on the question. With the new construction project, it appears that the Title 24 report will provide data needed, will not have actual products. If you can clarify that question, that'd be great. I'm not really too clear on that. Can you define modeled loads? So modeled loads, we'll go into that later, but I'll just show you the gist of it. When you're doing your calculations, you'll see loads modeled basically for each end use. So here's our domestic hot water loads, and here's our heating, our space heating and our space cooling loads. That's what I meant by loads in Energy Pro. Okay, so I already went over the pump section. Let's see, we already went over the air tap. Oh yes, you definitely, if you have a central system, you definitely want to, there's a little checkbox in the domestic hot water tab that says that it's a central system. You definitely want to click that. So loop set points for hot water boilers. I'm not going to get into engineering specifics. I'm only going to be getting into overall modeling requirements. And so just, I think that's more of an engineering question. So I don't think Energy Pro asked me for loop set points. If it does, if someone can please clarify that. I'm not sure if I've seen that. Okay, any go-arounds for modeling a steam to hot water conversion? No, but I'll look into that. So if you can email me, Rachel, later, and I'll look into that. But I don't know any workarounds from conversions from steam to hot water. Okay, so going back to the slides here. Okay, so when modeling your, so this is say HVAC systems, excuse me. So when modeling your HVAC systems, again, model your HVAC systems with the zones that are attributed with it. So in this example, we have different systems serving different floor levels. So you want to make sure that you call that out consistently and clearly, and don't if you decide to combine all systems, make sure they're a similar fuel type and you average their efficiencies. But if they're different fuel types, you definitely want to split out your systems. So this is the HVAC system setup. So when you click the systems description, you'll see this box come up. And again, this is what you'll set up as far as your system type and the fuel type, and you want to look at your efficiencies. This is mainly what Energy Pro is looking for when it's doing its load calculations. And of course the fan tab, heating, cooling, and fan tabs. And again, the fan tab is only if you have your air handler blower. Okay, so what Energy Pro uses for HVAC load calculations. So the 2008 Residential ACM Manual, Section 3.9, HVAC System Overview shows detailed calculations for proposed and designed loads. For high-rise, the 2008 Non-Residential ACM Manual, Section 2.5, HVAC, not HVAV, systems and plants show detailed calculations for proposed and designed loads. So the alternative section, this is the section at the end of Energy Pro, which where you'll model any kind of differences in your baseline tree, and Energy Pro can calculate the savings based on if you decide to go with a more efficient system. So again, you always want to make sure things are feasible before putting them in the scope of work. Especially with HVAC systems, you definitely want to make sure you can have clearance for any flues, any kind of exhaust issues. If you're changing out fuel types, make sure their savings can be shown, or if there are reductions. There can be reductions in some cases, so I'll be advised on that. Multi-zone variable refrigerant flow systems have good potential energy savings. Of course, going to a sealed combustion or condensing steam or hot water boiler. Improving your HVAC distributions, like your ducts, making sure all the ducts are insulated, to recommended R8. Reduce duct leakage from test and assessment, preferably to a passable HERS percentage. And it's also a good practice if there's cooling to do a systems performance verification using HERS protocols for their refrigerant charge, airflow, and fan watt verification. So baseboard radiators and wall unit tune-ups are also good low-cost solutions to improve efficiency, but there aren't any credits in Energy Pro for such improvements. Okay, so I'm going to look at the questions real fast. Okay, so it's been my understanding that evaporative coolers aren't mechanical systems, and shouldn't be included into the model. This is what I've been advised on. I'm not sure. I haven't dealt with a whole lot of systems that have evaporative cooling, but from my understanding, evaporative cooling isn't a mechanical system and it should not be included in the model. But there are tabs in Energy Pro where you can include evaporative cooling information. So I basically would just look at what inputs Energy Pro is asking you for evaporative cooling, find out what kind of evaporative cooler you have and its components, and put in each of those system components, and they're mostly related to pumps. Okay, so it looks like that's it for questions. So the common calculations you'll find in Energy Pro. So a good calculation method is the loads, and this is typically used to get heating and cooling loads for each of the zones you modeled in the building tree. So I'm not going into the details with the zones. We'll go into that in a later webinar. But if you have correctly set up your model with the correct system serving the correct zones, when you do a load calculation, Energy Pro should spit out what the load is for heating and cooling for each of those zones. So that may be a good recommendation if you're an HVAC contractor or even trying to troubleshoot heating and cooling issues in some of the units. So the next is the most typical usage for Energy Pro is the residential Title 24 compliance. That's typically used throughout California building departments to show energy compliance. This calculates a model based on a baseline and your building tree. So it takes a baseline based on some modeling assumptions, and it compares that to your building with all the improvements, and it gives you a percentage compared to a Title 24 baseline. And given your jurisdiction, you might have to beat it more than 15% or more than 20%. So make sure you know what your local jurisdiction is requiring for passing Title 24 requirements. And also another heavily used module is the residential Greenpoint rated module. This is typically used by Greenpoint raters in the Greenpoint rated program. And this module calculates the building score based on the vintage. It gives you a score that you need to meet Greenpoint rated. Basically, the score to meet Greenpoint rated, it's an index number, or a score, excuse me. And then it basically uses three numbers: a test-in number, a vintage, what we assume, and what you actually modeled as far as improvements. And your improvement, whatever you model as far as your improvement, should be better than what our Greenpoint rated score for compliance should be. And it'll tell you when the GPR 1R if you pass or not. So another highly used module is the CalCerts. It's not particularly used in the multifamily realm, but it is used a lot in the single family realm, and it'd be a good idea to help coordinate maybe your HERS index scores with a multifamily building, even though there aren't any approved methods for HERS index scores for multifamily buildings. But it may just be good practice just to get used to it if you're a HERS rater. Also another module that's widely used is the residential performance module. That's also known as the Energy Upgrade California. Residential and non-residential performance. So if you're down in LA, I know a lot of the folks who participated in the pilot program got acquainted with the non-residential module, and that was the first time I got acquainted with the non-residential modules, non-residential performance module. And so this module basically compares, just like with the Title 24, a baseline, which is your building model tree, and your alternatives, whatever you model as far as performance upgrades. And it gives you results in either a site or a TDV, and these savings percentages can be used for rebates. Okay, so again, troubleshooting, calculation results. So when you do an Energy Pro calculation, in the very bottom you'll get this pretty little matrix that'll show up. And each of the alternatives that you model in will have a line item or a row, and each of the loads will have a column. So all the modeling inputs you put into the energy modeling or the Energy Pro tree will get calculated using the ACM manual, and it'll spit out loads in each of these rows. So if you're seeing a reduction, that means your alternatives are modeling improvements. And inversely, if you're seeing, like here I put in a little section on fans, you can see a big jump from 15 to 63, and that's a problem. That means something was modeled incorrectly into the building tree. And in this example, there was a huge fan load that was modeled into the HVAC fan tab for a bunch of for the system called out hydronic radiators, but there was fans modeled in. So this project wasn't complying or meeting any green point rated index or even showing any savings because of this huge fan discrepancy. So when you're doing your calculations, it's always a good idea to check this and just to see if the numbers are showing reductions and not increases. And that way you know things are should be modeled consistently. And if things are showing an increase, that's where you can actually find where your problem points are. So here in the fan section, I was able to know, okay, oh, this is the fans. It's either in my residential tab where I put in my exhaust fans, supplying exhaust fans, or in my HVAC system icon with the heating and cooling and fan tab where you put in the blower. So those are the two places I'm going to be looking for fan energy, and if there's an issue with that modeling or if the inputs are incorrect. Okay, so that about wraps up HVAC plant systems. So as far as help and support, the Energy Pro user manual, this is great for navigating if you're new and if you don't understand what each of the icons are for or what the inputs are asking you for. This is a great resource to go to. There are also Energy Pro YouTube videos from Bill Green and Martin Dodd. They're basically quick tutorials on residential residential buildings for the most part, not really multifamily. I do plan on putting together multifamily YouTube videos within the month, so those should hopefully be up soon. Energy Pro support. So you want to email EnergySoft support if you have any technical questions regarding software, like if there's an issue with your software, like, oh, the screen's not showing the OK button, or anything related to, like it's not updating like it should be. That's when you should email support. If it's general modeling questions, you can always email us. That is if it's a green point rated project. You can email the applicant expert, or if you're working on Energy Upgrade California, you can email the buildinggreenutility.org address, and those should be forwarded. Those get forwarded. Most of those get forwarded to me, or the questions get forwarded to me. So those are good places to contact if you have questions or concerns. And so that about wraps it. I think I'm a little bit ahead of schedule, so I'm going to go ahead and go over the questions again. I don't really see too many, but if you have any, Yeah, the slides will be handed out at the in the presentation. Diana will I'll get these to Diane, and we'll get it sorted out in ways for you guys can download it. Okay, so that about wraps it. I appreciate you all for sitting in this webinar on plants and HVAC systems, and hopefully I helped you all better understand what it is Energy Pro is looking for as far as modeling inputs, what it is you can do to improve the building as far as savings, and what you can do to maybe have some more low-cost, high-saving, or greener options. And thank you all for attending. I'm going to hand this right back over to Diana to close us out.
Yeah, thank you so much for the presentation, Sean. Very informative. Thank you, everyone, for attending. If anyone has any questions, please contact Sean directly. He'd be more than happy to help. And we do have another multifamily webinar coming up. It's titled Envelopes for Combined High-Rise and Low-Rise. That'll be on April 17th. I hope that you can join us for that as well. Thank you, everybody. Have a nice day and happy spring.